June 2025. Over the course of merely 4 evenings, a warning from the Atlas Observatory spotted a brilliant speck racing across our solar system at close to 152,000 miles per hour, quicker than any recorded asteroid and clearly originating from outside our system. NASA verified the detection. This turned out to be 3I Atlas, merely the third extraterrestrial body ever observed arriving from beyond the Sun. Yet the developments that ensued shattered all expectations. Its luminosity seemed excessive relative to its dimensions. Its trajectory, when projected backward into the galaxy's core, revealed eerie irregularities that no comet could account for. Certain experts are now suggesting it might be something beyond mere stone and frozen gas, perhaps an experiment, a caution, or even a communication. So, what ultimate indication did 3I Atlas truly transmit? And why is the planet so tense at this moment? The overnight team at Atlas in Chile monitored the incoming data flow, alert for any anomalies. On June 25, 2025, the automatic notification system highlighted a dim, swiftly traveling light source that didn't align with any documented asteroids or comets in the database. The log showed RO 3117 UTC. In short order, the software classified it as a high-priority prospect, sparking a series of verification protocols. During the subsequent 4 nights, every moment of clear visibility mattered. With each telescope sweep, another coordinate joined the expanding path. By June 29th, the entity's movement was undeniable. It was carving through the heavens at a velocity that left even veteran skywatchers stunned. The chance for spotting it was exceedingly narrow. Stellar fields close to the Milky Way's bulge almost concealed its route. Only by integrating Atlas's swift analysis process with historical shots from the Zwicky transient facility did the group uncover that the body had actually appeared as far back as June 14th. Nevertheless, the formal observation period from June 25 to June 29 marked the slim margin between a groundbreaking discovery and an overlooked event. Hour by hour, the intruder widened its separation, its course drawing it outward from the solar system's heart. Chat rooms and urgent phone calls hummed as the Minor Planet Center got the initial notice. NASA's endorsement came within 24 hours for the Atlas graveyard shift. The truth dawned on them. They'd just nabbed the third interstellar intruder in history, and time was slipping away. Specialists in orbital mechanics at the Minor Planet Center dove into calculations the instant the location info hit their systems. The flight path wasn't merely odd. It defied mathematical logic for anything orbiting our star. The arc plotted by 3I Atlas describes an unbound hyperbolic trajectory with an eccentricity well exceeding one. Simply put, it's hurtling along at over 152,000 passion, far too rapid for the sun's gravity to recapture it. Astronomers term this hyperbolic excess speed, a velocity so immense that despite the sun's gravitational grasp, the visitor simply resists and presses onward. The figure's direct origins toward the Sagittarius constellation, adjacent to the Milky Way's crowded nucleus. Such an alignment isn't coincidental. It suggests a birthplace buried in the galaxy's depths, distant from the scattered disk or even the Oort cloud. The incoming direction and pace eliminate any possibility of it being ejected from our own system. No identified planet or listed body could have imparted such acceleration. Measurement squads performed multiple orbital computations, all reinforcing the identical conclusion. The visitor's pace and direction indicate it's not lingering, it's transiting, gone forever. The prior 2 interstellar arrivals, Oumuamua and 2I Borisov, displayed comparable hyperbolic routes, yet 3I Atlas distinguishes itself through its extreme speed and the accuracy of its orbital mapping. Each fresh measurement strengthens the evidence. This is a cosmic wanderer, a dispatch from realms beyond our ken. Light measurement groups at the Vera C. Rubin Observatory toiled overnight, capturing every bit of radiance from 3I Atlas. The results simply didn't compute. For a core measuring slightly more than 11 kilometers in diameter, the glow was extraordinarily intense, even prior to the comet's During its nearest pass by the Sun, the object's coma extended to almost 24 kilometers across, forming a hazy envelope of particles and vapor expected to fade as it spread out. Yet 3I Atlas glowed with a sharp, nearly metallic luster. Albedo, the measure of reflectivity, quickly became the key term on everyone's lips. Typical comets within our solar system send back only a small percentage of the sunlight striking them. This visitor reflected a much greater amount, aligning it more with pristine ice sheets or burnished metal rather than rough, powdery stone. Observations from Rubin, cross-verified with Atlas and Gemini South, solidified its anomalous profile. The exterior seemed so luminous that certain photometry experts speculated about a cavernous interior or a covering of exotic frozen compounds. Some suggested an extremely spongy makeup where light diffused across myriad minuscule facets. However, no documented comet or asteroid in the records exhibited this precise profile. The core proved too sizable for such intense brilliance. The surrounding haze displayed too even a distribution for standard vapor release. With each fresh image, the enigma intensified. Should the outer layer indeed possess this degree of reflectivity, it would compel scientists to reconsider the endurance of interstellar wanderers during voyages across the void. The next step involved advocating for finer detailed examination, achievable solely via the James Webb Space Telescope. As 3I Atlas emerged from the Sun's blinding light, the James Webb Space Telescope's viewing slot activated, offering researchers their initial opportunity to uncover its authentic composition. The mid-infrared instrument, or MIRI, charted the entity's heat output over a complete spin cycle. Rather than erratic thermal variations, focal hot zones, or indicators of sprays or outflows, the readings indicated a consistent, nearly even radiance. The warmth distribution suited an entity rotating with precise rhythm, unlike an irregular frozen fragment careening through the cosmos. The brightness profile recurred every 6 hours. Lead researcher Dr. Sato called the rotation remarkably consistent for an object of its scale. NIR-SPEC, the James Webb Space Telescope's near-infrared spectrometer, hunted for signs of fleeting compounds. The analysis uncovered a haze rich in carbon dioxide, though the traces were scattered, lacking focused jets or abrupt spikes. The central body gleamed with a clear metallic sheen, reinforcing terrestrial hints of an exceptionally even or potentially angular exterior. Still, despite this luminosity, no substantial vapor emission appeared capable of altering the path. Exact positional measurements served as the ultimate test. Across 2 months, the James Webb Space Telescope, alongside terrestrial observatories, monitored 3I Atlas's location to within milliseconds. The findings revealed any gravitational deviations, be they from outflows, light pressure, or rarer influences, below 1/10 to 7 meters per second squared. Effectively, the entity traveled under gravity's sole influence, without detectable deviation or mysterious propulsion. As Dr. Avi summarized, if an onboard drive exists, it's more silent than any we've encountered. Avi's criteria for artificial makeup resemble a detective's blueprint: unaccounted momentum shifts, exceptional shine, absence of emissions, and contours or rotation bucking organic norms. The team overseeing 3I Atlas aligned every datum against this framework. No detectable non-gravitational motion. JWST and surface groups established bounds, stricter than for prior cosmic intruders. The shine level stands elevated yet not unprecedented in nature. Emissions occur, albeit subdued. The rotation persists steadily, without chaos or hints of deliberate design. Each benchmark requires meticulous records, though initial positional and spectral data occasionally face brief holds, sparking discussions. Formally, releases adhere to routine validation periods, spanning days rather than weeks. Yet for such an uncommon event, each moment of wait invites examination. The system built for thoroughness can seem evasive under global gaze. 3 cosmic intruders, each with distinct tales. Oumuamua, the pioneer, sped past San's coma, and with a form that it challenged all established classifications. Slender and stretched out, it sped up for motives that baffled experts. Borisov II showed up like a textbook comet, releasing vapors and particles exactly as models foresaw, yet it raced quicker and glowed more intensely than any local solar system wanderer. Today, 3I Atlas muddies the distinctions. It sports a wide envelope reminiscent of a comet, but its core radiates with an evenness and luminosity suggesting an unfamiliar type. Scientists label it a blend, not purely comet or asteroid, but evidence that the cosmos holds more variety than our manuals describe. Every such meeting stretches our horizons, heightening the challenges in detection methods and understandings. An upcoming radar scan at perihelion in late October might uncover details or motions overlooked until now. In the meantime, observers everywhere keep vigil, eager to learn if this outsider will upend conventions anew. At the time of this update, the entity's real identity stays a mystery. One thing stands out: every fresh interstellar arrival strains our tools for spotting and examining them. Presently, 3I Atlas serves as an intriguing enigma and a nudge that discovering truths depends on shared information and worldwide examination. All right,